Your washing machine spins at speeds that would liquefy a human body, yet somehow it cleans your socks. Most people think detergent does the heavy lifting. It doesn't. Detergent is just the opening act. The real work happens in two invisible stages: mechanical force and molecular disruption. Together, they're so effective that archaeologists use the same principles to preserve ancient textiles. So what's actually happening when that drum starts to turn? Let's start with something you can feel but never really see: the wash cycle itself. When water and detergent mix with your clothes, they're not just soaking. The agitator, or in modern machines, the drum, moves back and forth at roughly 40 to 60 times per minute. That's not random jostling. It's friction. Deliberate, relentless friction. Friction is where dirt loses. Soil particles, bits of skin, dust, fabric fibers cling to cloth through weak chemical bonds called van der Waals forces. These bonds are fragile. When fabric rubs against fabric thousands of times in a few minutes, those bonds snap. The dirt particles break free, but they don't just float away. This is where detergent enters the story. A detergent molecule is shaped like a tiny fork. One end loves water, the other loves oil. That matters because dirt isn't always dry. It's often mixed with body oils, cooking grease, and sweat. Detergent molecules surround these oily particles, trapping them in microscopic bubbles called micelles. Now the dirt can't reattach to your clothes. But the cycle isn't over. Water temperature matters more than most people realize. Hot water speeds up molecular movement. The detergent molecules move faster, the fabric fibers move faster, everything accelerates. Cold water still works, but it's slower, quieter, less aggressive. That's why delicate fabrics survive cold cycles. They're literally being jostled less violently. Then comes the rinse cycle. Your machine drains the soapy water and floods the drum again multiple times. Each rinse removes another layer of detergent and suspended dirt. This is crucial. Leftover detergent makes clothes stiff, dull, and itchy. The rinsing isn't secondary, it's essential to the whole process. And then the spin cycle begins. This is where physics becomes almost violent. A typical spin cycle reaches 1,000 to 1,600 rotations per minute. At the outer edge of the drum, that creates outward forces around 300 times the pull of gravity. Your clothes are pinned against the drum wall by sheer centrifugal force. But here's what's beautiful: water weighs more per drop than fabric does. At those speeds, water can't stay embedded in the cloth. It's flung outward through the drum's perforations. Clothes stay behind because they're lighter. It's a separation based purely on mass and acceleration. No pumps needed, no filters, just spin. The whole cycle, wash, rinse, spin, typically takes 30 to 45 minutes. In that time, your machine has created an environment where friction, chemistry, and physics all converge. Dirt particles are broken free, trapped in soap bubbles, rinsed away, and then literally expelled by centrifugal force. It's elegant, almost surgical. What's remarkable is that this system barely changed in 150 years. The earliest electric washing machines, around the early 1900s, used the same core principles: agitation, detergent, water, and spin. We've refined the engineering, added sensors, made it quieter. But the physics hasn't shifted. It's still friction and chemistry doing the real work. Which brings us back to the original question: how does a machine conquer dirt? Not through magic, through relentless mechanical persistence. Every fiber is rubbed thousands of times. Every oil molecule is surrounded and isolated. Every drop of water is expelled with forces that would seem impossible in a living room. Your washing machine is quietly violent, and that violence is the whole point. Subscribe so you don't miss the hidden physics behind the ordinary. There's a new one waiting every week.